Hello everyone. Today we will be implementing depth first search for a graph. First of all, I would like to explain what depth first search actually means. In simple words, we can say that for a node, keep going to first unvisited neighbor. What that means is that suppose a node has a neighbor as 1, so unvisited neighbor as 1, so go to that neighbor. Now 1 has an unvisited neighbor of 2, so go to that 2 neighbor and keep going for each neighbors. For each neighbor you have to find their own neighbor, so you will feel like okay, for each neighbor we are finding their neighbor, and for that neighbor I am finding their neighbor. So we get a recall that we are doing same thing again and again. So what does that actually mean? It means recursion, backtracking. This is what we actually need to do for a DFS. The most, I think, famous and general and easiest approach is to go with recursion, though we can also use exclusive stack for this too. But for now, I think using a recursion would be better approach, and its code is smaller and simpler to understand. So yeah, let's implement it. So this is a template for a graph that I have already made. So let's make a function DFS, and what do we want inside our function? First of all, our node, this is the node from which we are going to calculate its neighbors, and I will also maintain a boolean vector visited, so that we can actually check if that node has been visited or not. So I'll take a integer u vector boolean, I'll name it as visited, and let's write this function. So yeah, the first what need to do in function, we will just print our node. So we are just going to print, that is the first thing we need to do in function, and I'll just mark our node as visited, that is vis is equals to true. Now next thing what we need to do is, for each node we need to iterate to all its neighbor, and for all neighbor we need to iterate to all its neighbor again. So yeah, so let's, for integer v, I'm taking it as v, iterating to every neighbor, that is all neighbors of u. If that node has not been visited yet, then I'm gonna call this function again, that is the visited function. I'll pass the parameter boolean vector. So this is the simple code for DFS. It's pretty small, that is why the exclusive stack method is a little bit lengthy, although both are the same. But I think as exclusive stack time complexity, I need to check. Oh, let's check it now only, that what is the complexity of exclusive stack versus recursion for DFS. So let's see what we will get the result. Both approaches have the same big of time, space and complexity, but they differ significantly in how they handle the memory. Okay, so the they both have time complexity, but they handle memory differently in order of operation. So both have the same time complexity, that big O of number of vertices and plus number of edges, and space complexity is same as well. for there we will be using stack. Here we are using a vector visited to save whether our node has been visited or not. So yeah, let's try to run it now, if we get the result or not. So we have to pass integer and vector as a parameter. So let's first define the vector boolean, who has, I'll name it visited, who has a size of 5, and all are currently false. And g, I'll call the function, yeah, I think this should work. So let's run it. Okay, we are getting an error here. Okay, I think I'm missing a bracket here. Let's run it again. So yeah, we got the output. The DFS traversal for this is 0 1 2 3 4. So yeah, it was an easy method. I hope you learned it. Thank you.